Okay, so this is assignment 6. Try and fix my camera. Sort of. Okay. So these are the answers. You should have checked them already. First one's no calculator exact. Probably have to show you guys how to do number 3. 4, 5, and 6. Those are the answers. Should have pictures and work, law signs, law cosines. 7, 8, 9, 10. Should draw pictures. Probably using law signs, law cosines. And units. You need units. AP test. If you don't put units, you lose points on free response problems. And not parts of points, whole points. 1 out of 9 points. You don't want to lose that on a free response question. So let's talk about how to do these. Number 1, this is just problems we've been doing. Reference angle 30 degrees, quadrant 2. And so sine of 30 degrees is 1/2 and quadrant 2 is positive. There you go. Done. Okay. Secant is 1 over cosine. And the reference angle is quadrant 3. It's past 180, 45 degrees past 180. That's the reference angle. Cosine of 45, sine of 45, that's the easy one to remember, is root 2 over 2. In quadrant 3, cosine is negative. So it's negative 2 over root 2, which is negative 2 root 2 over 2, which is negative root 2. So you guys should be able to do those quick without having to draw pictures. Now, number 3 is a little mean. So first of all, cotangent is 1 over tangent. So it's tangent upside down. Tangent sine over cosine. So this is going to be cosine over sine. Okay. But the bigger problem here is that the reference angle is 15 degrees or 75 degrees. It's quadrant 1, right? So that is the reference angle for both of those. But we don't have that one memorized. And it doesn't really boil down to a special triangle. So you're going to have to use something that you've seen before. Algebra 2, you should have seen this. But I haven't brought it up. It's called the angle addition identity for sine. And there's one for cosine also. So what this idea allows you to do is to think, well, what are 2 angles that you know that will add up to 75? 30 and 45, right? Now, sine of x plus y is going to be sine x cosine y plus cosine x sine y. So you just do those 2 angles. That one's hard to mess up because it's sine of one, cosine of the other, and it's plus the other way around. Now, the angle addition identity for cosine, you can mess up a little more. It's cosine x cosine y and sine x sine y. So you might remember that, but it's going to be the opposite sign that you have here. This one's going to be the same sign. So if it were subtraction, you'd actually get a minus here. And then the order would matter. But if this were a subtraction, this would be a plus. So anyways, we got to use those. So what we're going to do is we're going to say, okay, well, this is cosine of 30 plus 45, right? This is sine of 30 plus 45. And so at this point, you might go ahead and pause it and see if you can finish it yourself. You guys have done this before, okay? But for the cosine one, it's going to be cosine 30 cosine 45 minus sine 30 sine 45. And on the bottom, the sine one is going to be sine 30. Actually, yeah. So sine 30 cosine 45 plus sine 45, cosine 30. At this point, you guys are in the home stretch. Cosine 30 is root 3 over 2. Cosine 45 is root 2 over 2. Sine of 30 is 1/2. Sine of 45 is root 2 over 2. On the bottom, sine of 30 is 1/2. Cosine of 45 is root 2 over 2. Sine of 45 is root 2 over 2. Cosine of 30 is root 3 over 2. So now we just got to try and simplify those. I'm going to go up here. So that's going to be root 6 over 4, right? Minus root 2 over 4, all over root 2 over 4 plus root 6 over 4. So we could multiply the top and bottom by 4, right? And give you root 6 minus root 2 over root 2 plus root 6. Now you can't just cancel these, but we can, there's some different things we can do. We could take a root 2, divide a root 2 out of everything on the top and bottom. That would make it a little simpler. You'd get root 3 minus 1 over 1 plus root 3. And I'm fine with that as an answer, but we could rationalize the denominator. Now, the way you rationalize a multiple term denominator with irrational numbers is you multiply by the conjugate. And where we do the bottom, you got to do the top. Conjugate's the same thing with the opposite sign. The reason it works is because then you got to FOIL it, and the middle terms cancel out. And I'm running out of room. I guess I'll start over here. On the top, you're going to get root 3 minus 1 minus root 3. On the bottom, you're going to get 1. And if you did all the FOILing, you get minus root 3 plus root 3 minus 3, and these guys would cancel each other out. I feel like maybe I made a mistake on the top. Let's see, root 3 minus 1 plus root 3. So on the top, we have 2 root 3 minus 4, and on the bottom, we have minus 2, and then we can simplify it even further and say that it is negative root 3 plus 2. There you go. So some good fun times. Now, just to alleviate your stress, I'm not going to do that on your next test, okay? But yeah, we'll just throw a little other trig in there. But probably won't really need to use that this year, at least in the College Board's AP Calculus AB exam. Calc C, we got to bring back some other trig identities. Double angle identity for cosine, which comes from this angle addition identity for cosine. So that's how you do it. But you guys should have seen that before, but maybe it's been a while. Now, for the serious new stuff, the rest of this worksheet. Now, one of the things I told you guys is you should just draw a picture. I mean, I don't know how you're going to figure this out without a picture. It's going to be a lot harder. We could say A, B, C. It really doesn't matter. I try to make sure this triangle doesn't look like a right triangle, which it almost does if you look at it just right. I don't want it to look equilateral, equal angular, or isosceles. I kind of want all the sides to look different and the angles look different. Most likely they are. Put the ones you know. Now, little b has to be across from big B. We don't know that. Little big A, we don't know. Little a is across from it, and we know that. Big C, we don't know. Little c is across from it, is known. So then the next thing you should do is which of those 3-letter kind of triangles is this? Is this SSS, side, 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 angle, 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 AAA? And you got to make sure. So this is side, angle, side. Now, some people might be like, oh, but what if it was like side, side, angle? No, you can't jump across these other unknown angles and sides. They got to be connected. Okay? Side, angle, side. Okay? Now, what that does is, first, I think, and most importantly, it tells you there should be one unique answer. Okay? We don't need to be looking for second solutions or testing to see. That would be ASS. That's the only one we got to worry about that on. Okay. Now, you could memorize that SAS requires law of sines or cosines first or whatever, but I would do that. I would just start writing law of sines because usually we're going to use law of sines. So I'm going to just start writing it down. Sine of A, which we don't know, over little a, which is 5, equals sine of B, which is 60, over little b, which we don't know, equals sine of C, which we don't know, over little c, which is 8. Now, from here, you're probably going to use this eventually if you have to solve the whole triangle. But this tells you that you can't use law of sines yet because you need, if you match any two of these pairs up, there's got to be one unknown. And any way you match this up, you're getting two unknowns. So we definitely have to go to law of cosines now. Now, law of cosines, we're going to focus on the fact that we have this angle B. So when we do law of cosines, we know that B little b squared needs to be over here because cosine B is going to be over here, right? And if b squared is here, then a squared and c squared over here. It's like the Pythagorean theorem. It's not, but it's like it. Minus 2ac cosine of angle B. So I always write that down. Now I don't memorize that. I memorize the pattern. There's 3 variations of this. I don't remember any of them individually. I just remember the pattern. Okay, so now here's the cool thing is we're actually looking for B. So this is going to work out. So a squared is 5 squared minus c squared is 8 squared minus 2 times 5 times 8 times cosine of 60 degrees. Now let's try and not use a calculator as far as we can, okay? So b squared equals 25 minus 64 minus 80. Now, what's cosine of 60? You guys know that. Cosine of 60, that's a 0, 30, 45, 60. 1, root 3 over 2, root 2 over 2, 1 half. And it's quadrant 1, so it's positive. So I don't think we need a calculator for this one. This is going to be, let's see. I don't know why I wrote a minus there. It's supposed to be a plus. So that's a 89 minus 40. So b squared equals 49. Square root of both sides. Plus or minus. I want you to write plus or minus. Algebraically, there's 2 solutions. Geometrically, we only want the positive one. There you go. Now, if we had to keep finding the other unknown sides of this triangle, we would then dump this into law of sines and find the smaller of the 2 angles, angle A, and then use the sum of the angles of the triangle to find angle C last, just in case it turns out to be obtuse. Because in our calculator, we don't want to rely on our calculator inverse trig to do that right. So this is the kind of work you should show. Draw a picture. This is my generic triangle. A, B, C, little a is 29, big B is, or little b is 47, little c is 32. What scenario is this? This is side, side, side. So do we need to worry about 2 solutions, 1 solution, no solutions? Nope. We could set up law of sines right away. Sine of capital A over little a is 29 equals sine of capital B over little b is 47 equals sine of capital C over little c is 32. Can we use law of sines right now to find something? Nope. So we're going to have to use law of cosines. Now, should we really kind of could write this anyway. Should we find angle A first, B first, or C first? You go, oh, let's find B. Do you guys remember the rule? If B ends up being obtuse, you're going to get this problem wrong. Okay? So let's go with the smallest angle. Smallest angle. That's the general rule. So we're going to do little a squared equals b squared plus c squared minus 2bc cosine of a. So we're going to find the smallest angle first. Okay, that's the safest way. So we're going to plug 29 in, 47 in. Now these are some big numbers, so I'm going to go ahead and use my calculator, I think, to help me do some of this number crunching. And then we're going to find cosine of A. So on my calculator, let's see what we get. 29 squared is 841. 47 squared is 2209. 32 squared is 1024. Minus 2 times 47 times 32 is 3008 cosine A. 841, we can add these. So 2209 plus 1024 is 3233 minus 3008 cosine A. Now we cannot combine these together. That would violate order of operations because you do subtraction before multiplication. So we're going to move this over here. So 841 minus 3233, negative 2392. Divide both sides by that. So we're keeping things exact now. So then angle A is going to be inverse cosine of this. And we can feel safe that on our calculator, when it gives us an acute angle every time, that it is indeed acute. So inverse cosine of 2392 divided by 3008 is 37.324643. Now I'm carrying extra decimal places because I'm going to use this for another calculation. Now what I would do with this is put this into your law of sines and then find the next smallest angle, angle C. Okay, so let's see if we can fit this work on here. So we're going to plug this into here and find angle B. So I'm going to cut to the chase. I'm going to say angle B equals inverse sine of, you're going to multiply by 47 sine of 37.324643 divided by 29. So you see what I'm doing? I'm going to solve for B, multiply by 47, plug the A value in, and then take inverse sine to get this. And on my calculator, again, I should feel confident that my calculator is giving me the right answer. Now, here's a little trick. 47 times sine of the previous answer, so then you don't have to type it in, divided by 29 is 79.318762. Then lastly, angle I messed up. I was trying to find angle C. Gosh dang it. Smaller angle next. Okay. So inverse sine 32 sine of 37.324643 divided by 29 is 41.994118. And then angle B is going to be 180 minus angle A minus angle C. So 180 minus the previous answer we just found minus 37.324643 is 100.681238. Now, final answer, 3 decimal accuracy, rounded truncated 681 degrees. Actually, the direction said to the nearest tenth. So I guess I should do 100.7 degrees. Nearest means round for sure. Okay? All right. That's the safe way to do it. Small, medium, large. Okay, next one, we're going to draw a picture. A, B, C, little a, little b, little c. C is 75. A is 54. Capital A is 29. Ooh, I just got lucky because this is an ASS problem. All right. And I really like to draw my ASS triangles like this with the first known angle here, the second the next known side here and the second known side here, so I can imagine it swinging. So I can draw the height in the correct way. It has to be the height. Any triangle has three different heights. You guys all know that, depending on the way you orient the triangle, right? But this is the height we want, the one that goes between the two sides. So we want to predict right now, is this a two solution, one solution, or no solution problem? Now, first thing we should check is this guy bigger than this guy? Because if it is, it's one solution. No doubt. It isn't. So now we need to calculate the height. So we say, okay, let's do a little basic trig here. Draw the height in, little right triangle, sine of 29 equals opposite h over 75. So h equals 75 sine of 29 degrees. And we'll calculate that real quick. 75 sine of 29 is 36.360721. Is our side bigger than that? It is. This is bigger than h. So that means we're getting two solutions. Okay? Two solutions. All right, let's set up law of sines. First thing, sine A is 29 degrees over little a is 54. That's a good sign. Sine of big B over little b, we don't have that, equals sine of big C over little c is 75. So we can go ahead and use law of sines to find angle C. There are two solutions. So we got to remember our calculator is going to give us, so angle C is going to be inverse sine of 75 sine of 29 degrees over 54. So I want you to write this down because some of you guys aren't good at using your calculators yet. And this would tell me, well, at least you know what you're doing other than you just don't know how to use your calculator, I guess. Inverse sine of 75 sine of 29 close parentheses divided by 54 equals 42.325892. Okay, that's actually one of our answers. That's the acute triangle. Now remember, when this swings over here, it creates the obtuse version, and you get this isosceles triangle, and the angle we just found right here is also the angle right here. And so the obtuse version, the second solution for this angle, which I like to call C star, is just 180 minus angle C, because they form a linear pair. So I could do 180 minus the previous answer. So I get 137.674107. And that's the obtuse one. You know one of them is going to be acute, one's going to be obtuse in this two solution situation. Since that's all they asked us for, then we could say, well, one of the answers is 42.3 degrees, and the other one is 137.7 degrees. We have to round one decimal place according to the directions. Now, if you had to keep solving the triangle, what you would do is you plug these in one at a time. Well, actually, you'd find angle B, because now you have two of the three angles of a triangle, and you know they add to 180. So you would just subtract this and angle A from 180 to get angle B and angle B star. And then you could use law of sines to find little b and little b star. But we're not being required to do that, so we can stop at this point. This is the kind of work you need to show. This is the kind of work you need to do. All right, now for these word problems. They're just these same problems in disguise with words. Parcel of land is in the shape of an isosceles triangle. Let's just draw an isosceles triangle. Two equal sides, two equal angles. The base of an isosceles triangle is the unequal side. Fronts on a road and has a length of 562 feet. If the legs meet at an angle of 22 degrees, how long are they? That's these guys. So we could put we create a variable if you want. Now, if these are 22, if this is 22 and these add to 180 and these are equal to each other, then that means there's 158 degrees left. Divided by 2 is 79 and 79, right? So what kind of situation do we have? We have, um, we need what 3 letters? Well, we could say we have angle, side, angle. We could also say we have angle, angle, side. Those are both one unique solution problems. I'm going to go ahead and set up law signs. Sine of 22 over 562 equals sine of, I don't have any letters on here, it's just sine of the angle over the side. So that's law signs. I always set it up just in case because it's an easy one. Can we use this to find x? Sure. So x equals, you could flip both sides upside down and then multiply by sine of 79. So I'm leaving out a little bit of just the arithmetic steps here. You could show it if you want. That's the exact answer. So 562 sine of 79 divided by sine of 22. Ooh, that's really big, but I guess that's it. 1472. Now, there's nothing in directions here. I mean, you might assume that we should follow the directions from part 2, but I'm going to go with, let's do 3 decimal accuracy, rounded or truncated. So either that or that. But I would like to see your exact answer also, okay? And, oops, don't forget, these actually aren't degrees. These are feet. Feet. On your next test, you don't give me the units or the wrong units, losing points. Okay, next one. 2 angles of a triangle measure 70 and 67. Okay, let's just draw it. Generic triangle, 70 and 67, which means the last one's got to be what? That's 137. That means it's got to be 43, right? If the side opposite the 70-degree angle is 30 centimeters in length, then how long is the shortest side? Well, the shortest side's got to be the one across from the smallest angle. So I'm going to have law signs. Sine of 43 over x equals sine of 70 over 30 equals sine of 67 over, I don't know, something else we don't know. Do we need it? Nope. We can find x right here. Law of sines. So, the trick I've been doing in my head is flip both sides upside down to get that variable in the top, and then multiply both sides by sine of 43 to get rid of it there. So there's your exact answer. 30 sine of 43 degrees over sine of 70 degrees. So I want to see this exact answer. Okay, don't start putting decimals in the work before you really have to. So sine of 30 times sine of 43 divided by sine of 70 is 21.773 centimeters. This is the length of a side, right? 3 decimal accuracy, rounded truncated. Okay. Now for number 9. The top of a vertical tree broken by the wind hits the ground 25 feet from the foot of the tree. If the upper portion makes an angle of 30 degrees with the horizontal ground, what is the original height of the tree? Okay, let's see if we can imagine this. You have the ground, you have a tree, and it got broken down, right? Now, if it had totally fallen on the ground, then you wouldn't have this 30-degree angle they're talking about. The top of a vertical broken tree hits the ground 25 feet from the foot of the tree. So that's what that is. You got to draw a good picture for this. Otherwise, I don't know. How are you imagining this? What is the original height of the tree? Okay. The original height of the tree is going to be both of these sides added up. Now, here's the trick. This is actually a right triangle. So we don't need law of sine, law of cosines. Law of sines, law of cosines was created for non-right triangles. If you have a right triangle, sure, law of sines, law of cosines works. It's just really complicated and unnecessary. Basic trig, or hey, this is a 30, 60, 90. This would be 1, 2, root 3, right? Well, we call x 2x and x root 3. And you know this, right? So you can figure out what x is. That's x. And then 2x would be 2 times that. So the total height of the tree is x plus 2x, right? Or 3x, or 75 over root 3. We could clean it up. I could call it 75 root 3 over 3. And make it even nicer, 25 root 3. Feet. Now, for the calculator, that's good. That's perfect. 25 root 3 would be 43.301 feet. Need the units. Didn't need any trig really. Pulled that off with just 3069 triangle. All right, number 10. Now I'm warning you right now. Number 10, you're going to have something like this on your next test. Now, it won't be a surprise because one, I just told you it's going to happen. Two, you're going to see variations of this problem occur like 3-4 more times before your test on homework, pre-tests, extra credit review. You would be surprised if it wasn't on there, right? Okay, so let's see if we can get the hang of this. A vertical tree stands on a slope, a hill, inclined hill that's inclined at an angle of 10 degrees. So I usually kind of think left to right, not that you have to, but this is my slope of 10 degrees, and there's a tree on it. Now, trees grow straight up, okay? Not perpendicular to the ground, but perpendicular or parallel to gravity, because they rely on gravity to pull nutrients down the trunks, and water goes up the trunk, and they like to go towards the sun also. So I don't know if you guys have ever seen like at In-N-Out, their logos like this, right? It's the 2 palm trees that are crossing each other. So a lot of times when they build a new In-N-Out nowadays, they put in these mature palm trees and they plant them sideways like this. And then if you've ever seen In-N-Out that's been there long enough after they did this, this is what the palm trees look like. They're sideways, but then they keep growing, but they want to grow upwards. So they kind of look like this, which is not the logo. But trees like to grow straight up. Anyways, whatever. Different now. So here's my tree growing perpendicular, parallel to gravity, perpendicular to horizontal. Okay. When the angle of elevation of the sun measures 25 degrees, the shadow of the tree down the slope. So trees cast shadow down the slope. So that tells you it's down here. So here's my shadow. If they said up the slope, I'd draw it up here, and that changes everything. But this will help you figure out where the sun is. So connect the tip of the tree with the tip of its shadow, and that's the rays of the sun, and draw the sun. Now it says that the angle of elevation of the sun, well, angle of elevation is also connected to angle of depression. And this is the angle of depression. Angle of elevation is up here. And so this is also 25 degrees because they're parallel lines with a transversal, create corresponding angles, alternate interior angles, all kinds of special angles that you guys learned about in geometry. Okay, the shadow is 40 feet long. 40 feet long, okay? And we want to know how tall is the tree. Let's put a variable there. Now, all I've done is interpreted all these words into a nice picture. But that is one of the biggest challenges, because if you draw the wrong picture, you have no shot. So get the hang of just drawing the pictures. Now, how do you guys see the triangle that just got created? Is it a right triangle? Nope. There is a right angle right there that makes up part of that angle, but what we need to bring in is draw some horizontals at every intersection, at every corner, because what happens is you get a bunch of special angles. If that's 25, that's 25, and that's 25, right? And this forms a 90 because trees grow parallel to gravity, and that's a 90. So if that's 25, this has to be 65, right? And this is 10, so that means this is 10 right here. So that means this is 10, and that means this is 10, right? And 25, this whole thing is 25, so the angle inside the triangle is 15. You guys see how that works? This would be 25 alternate interior angles, but then you have these corresponding angles. That's 10, so that's got to be 15 inside the triangle. Okay. And by the way, right here, this one, this is 10 and this is 10. So we got a lot of stuff going on here. Our picture is getting pretty busy. Probably want to draw these pictures bigger than I drew right here. The picture is key. But once you've drawn the picture, let's draw the triangle on its own and just put everything in there that we found. 15, X, 40, 65, and this is going to be 100, right? This is what we're dealing with. So what kind of triangle do you have here? You could say it's SAS. You could say it's angle, side. Well, not SAS. Not even that. The X is unknown. So what it is angle, side, angle, or angle, side. Those are both legitimate ways to prove two triangles are congruent, which means they have one unique solution. Let's try set up law signs. Sine of, now let's do sine of 15 over x equals sine of, use the other known side angle pair, sine of 65 over 40. You could do the last one, but it's probably not going to help you. Sine of 100 over, we don't know. We don't need it. This is all we need. So now we're going to solve for x. And show me the exact answer. I want to see the exact answer. Don't start putting decimals in your work. That's annoying. You're going to write all those extra decimals in the middle of your work. Just keep it exact. Then on your calculator, we'll put that in our calculator. So 40 sine of 15 divided by sine of 65 is 11.423. Rounded truncated comes out the same. Units are feet. So, I'm telling you, we're going to have something like a tree on the side of a hill on your next test, but you're going to get some more practice coming up. But drawing that first picture, it's the first challenge. If you can't do that, then it doesn't matter what else you do. Got to draw that picture right. Okay. So, that's it for this assignment. I hope you guys are getting good at your law of sines, law of cosines, solving triangles, and also understanding the strategies of how to do these easier and how to make sure your calculators give you the right answers. So there you go.